Today, I want to talk about how to use transformation to sketch a graph. After watching the video, students will be able to sketch graphs of function under a reflection in y-axis, under an enlargement using y-axis as center, under a translation to the left or to the right. Before I start the lesson, I want to do a little bit revision about transformation. First one is translation xy. When x positive, we move to right, x negative move to left, y positive move upwards, and y negative move downwards. Next is reflection. Reflection is in a straight line. Then enlargement. When doing enlargement, there are two things we need to know, that is the center of the enlargement and the scale factor of the enlargement. Now the image of the enlargement depends on the scale factor. For example, there is an object P. If P is being transformed under an enlargement by using C as the center, when scale factor equals to 1, this means that that is the distance from the center to the object. When scale factor is greater than 1, this means that the image is further from the center. This means that the distance from image to center is greater than the object. When scale factor is less than 1, the image is nearer to the center. This means that the distance from the image to the center is smaller than the object. Now, when we want to sketch the graph of function by using transformation, we should start from the parent graph. So we need to know how to identify the parent graph for each of the function. So for example, y equals x squared is the parent graph of y equals 2x plus 3, because the original of x now is replaced with 2x plus 3. Then y equals x cubed is the parent graph for y equals 3x minus 1, because initially the x now it is transformed to 3x plus 1. Then y equals 1 over x is the parent graph of y equals 1 over negative x plus 3. So when we compare, we find that x now it is transformed to negative x plus 3. Then y equals 1 over x squared is the parent graph for y equals 1 over 3 minus 2x squared, because when we compare, we find that x initially it is x, now it is transformed to 3 minus 2x. Then y equals x square root of x is the parent graph of y equals square root of 3 minus x, because when we compare, we can see that x is now transformed to 3 minus x. And y equals cube root of x now transformed to y equals cube root of negative x minus 4. So means this one, cube root of x is the parent graph of cube root of negative x minus 4. Then y equals e to the power of x is the parent graph of y equals e power negative 2x plus 1. So we can see that the position of x now it is transformed to negative 2x plus 1. Then y equals ln x is the parent graph for y equals ln 1 minus 2x, because the original x now it is transformed to 1 minus 2x. Now when we do sketching graph by using transformation, so generally the graphs are simple. Then when we start from the parent graph, so means we must know what is the shape of each of the parent graph. So let's start from the quadratic function y equals x squared. Now the shape of y equals x squared, it is quadratic, it is U shape. Then followed by y equals x to the power of 3. This is a cube function and it is a S shape going up. And y equals x to the power of negative 1, which is equal to 1 over x. This one is the reciprocal function and the shape is a curve in first quadrant and third quadrant. Now for reciprocal function, there are two asymptotes. One is horizontal asymptote, one is vertically asymptote. Asymptote means when you sketch the graph, the curve will never touch the end of x-axis and y-axis here. Then after that, the other one is y equals x to the power of negative 2, which is equal to 1 over x squared, and the curve is in first quadrant and second quadrant. And also this function has got two asymptotes. One is horizontal asymptote and one is vertical asymptote. So these are the example of simple graph that you have learned before. Now we go to the second column. Now in case in front of the x there is a negative in front of x, means you need to do reflection of the curve by using y-axis to do reflection. So for example, the quadratic function in front of x has got a negative in front, so means you need to do reflection by using y-axis. But now when you see, because the U shape is a balanced shape, even you do the reflection by using y-axis, the shape is still the same. But when you come to x to the power of 3, when there is a negative in front, means you need to do reflection by using y-axis, so the shape will becomes an S shape and going down. Then reciprocal function, when there is a negative here, means you need to do reflection by using y-axis. Before reflection, the curve in the first quadrant, after reflection will becomes second quadrant, third quadrant will go to fourth quadrant. Then for 1 over x squared, in case there's a negative in front, means same thing, you need to do reflection. But because of this curve, that is a balanced curve, so even though after you do the reflection by using y-axis, it is still the same. Then now we go to some other function, which is square root function, y equals square root of x. The shape of square root of x is curved going up in the first quadrant only. Then when the x it is negative in front, so means you need to do reflection by using y-axis going to the left hand side. So after reflection, the curve is in the second quadrant. Then for x to the power of 1 over 3, initially the curve is slipping S going up, but in case there is a negative in front, means you need to do reflection by using y-axis. Then after reflection, the graph becomes a slipping S going down. Next, there is an e to the power of x. E to the power of x means that is the exponential. Exponential means that is something like index that you have learned before. For example, y equals 2 to the power of x. So the only different thing is 2 to the power of x, the base is 2. And when you come to e to the power of x, the base is e. Now e is the value which is approximate to 2.718. Okay. Then So this one is the constant. So means the curve is a curve going up with a critical point, which is the y-intercept as 1. And there is a horizontal asymptote for e to the power of x exponential function. So means when you sketch the curve, the end at negative x here, so make sure the curve will never touch the x-axis here. So in case there is a negative in front of x, okay, so means you need to do the reflection of the curve by using y-axis. So after doing reflection, the curve is going down, and the critical point 1 here, it is still the same because the 1 is at y-axis. Okay, then now there is an make sure the graph, the end of the graph will never touch the asymptote. Then next one is lone function. Lone function is actually logarithm. So lone means logarithm with base e. You have learned logarithm before, but the logarithm before that you learn is base 10. So now we learn logarithm with base e. So logarithm with base e, we call it as lone. Okay. So now the curve of lone, it is a curve going up with a spatial point that is 1, that is x-intercept. And for lone function, there is a vertical asymptote here. Okay, then when x it is a negative, so means you need to do reflection by using y-axis. So after doing reflection, the critical point 1 will come to negative 1. Now there are two kinds of transformation. One is x-coordinate transformation. The next one is y-coordinate transformation. So in this video, we learn about x-coordinate transformation. So when you're given a function, first you need to double check whether there is a negative in front of x variable. So in case there is a negative in front of x variable, means you need to carry out reflection in y-axis. Second step, you need to double check whether there is a constant in front of x variable. In case there is a constant a, means you need to carry out the enlargement by scale factor 1 over a by using y as the center. Third step is you need to double check whether there is a plus or minus a constant behind. In case there is a plus or minus b, means you need to carry out translation, shift the curve either to the left or to the right by b over a unit. Now we look at the example. Sketch the graph y equals lone negative 2x plus 1. So first thing we need to do is to determine the parent graph. So from the equation, we find that that is a lone function. So means the parent graph is lone function. So we start our sketching by using lone function. Next, we need to determine whether there is a negative in front. So we can see that there is a negative in front, means we need to do the reflection of the curve by using y-axis. So when the curve is reflected by using y-axis, the graph becomes like this. Okay, so that is the graph for y equals lone negative x. Next, we need to find out whether that is a constant in front of x variable. So we can see that that is a 2 here. So means we need to carry out enlargement by using scale factor 1/2 because there is a 2 here. And the enlargement should be done by using y-axis as center. So since the scale factor is 1/2, which is less than 1, means the image of the curve should be nearer to y-axis. So this curve is object. So the image of the curve should be nearer to y-axis, which is somewhere in between the object and the center. So means after enlargement, the curve should be somewhere here. Then now we look at the critical point, -1 here. -1 after enlargement will come to here. So now we look at the value. Initially it's -1. After -1, enlarged by using scale factor 1/2, we multiply with 1/2, so it is -1/2. So means this value will becomes -1/2. So means after the enlargement, the graphs look like this one. So we can see that this is the graph for lone -2x. Next, we need to see whether that is a plus or minus behind the x variable. We find that that is a plus. X means we need to shift either to the left or to the right. So in order to determine, well, we make -2x plus 1 equal to 0, and 2x it is equal to 1, so x it is equal to 1/2. So since x is a positive value, means we need to shift the whole curve to the right hand side by 1/2 unit. So means the every point of x should be shifted 1/2 unit to the right. So now we look at this critical point. Initially it is -1/2. After shifted to the right for 1/2 unit, then this point will go to 0. So means after the translation, the image should be like this. Okay, so after translation, the curve looks like this. Then here, I want you to see here, there is a vertical dotted line here. So actually, this one is the vertical asymptote of the function lone. Initially, before translation, the vertical asymptote, it is hidden, it is coincide with y-axis, and it is hidden behind the y-axis here. So when we do translation, when the curve will shifted to the right hand side, so this one will bring along the vertical asymptote. So means after shifted, so the vertical asymptote will come up from the behind of the y-axis. So now the vertical asymptote is no more hidden behind the y-axis. So now we need to draw the vertical asymptote by using dotted line, and we label it as x equals to 1/2 because we have shifted the whole graph to the right for 1/2 unit. So then we will get the graph. Now we look at another example. Sketch the graph y equals e to the power of 1 plus 3. So first choose the parent graph. So you can see here, since there is a e here, so means the parent graph is exponential function. So we can start from the exponential function. Next, we need to determine whether it is a negative in front of x. So here we can see that it is a positive. So if positive means no reflection by using y-axis. Okay, so no reflection by using y-axis. So after that, we go to the second. We double check whether there is a constant in front of x. So we find that is a constant in front of x. So means we need to carry out the enlargement by using scale factor 1/3 because of 3 here. So when we carry out the enlargement by using scale factor 1/3, the center is y. Y is center. So since the scale factor is less than 1, so means the image of the enlargement compared with the object will be nearer to y-axis. So here we divide into two parts. First part is on the right hand side. So after enlargement, since scale factor is 1/3 less than 1, so this is object, so the image should be nearer to the center. So means after enlargement, so the image should be this one. Then we come to this critical point 1. So since 1 is at the center, means all the point at the center is unchanged under enlargement. Then after that, we go to right hand side. So same thing, scale factor is 1/3 less than 1. So means the original curve is object. So means after the enlargement, the image should be nearer to the y. So means the image should be in between the curve and the y axis. So should be somewhere like this. So means after the enlargement, the graph looks like this. So since the exponential function has got an horizontal asymptote, so make sure when you draw the graph at the end here, the curve will never touch the x-axis. So last, we got to see whether there is a plus or minus a constant. So we can see that it is a plus 1. So means we need to do translation, whether to the left or to the right. To determine this, we make 1 plus 3x equal to 0. 3x it is equal to -1, so x it is equal to -1/3. Since x is a negative value, means we need to shift the whole curve to the left. So means each of the point will be shifted to the left. So after shifting, the graph looks like this. Here, I want you to look at the critical point for number 1 here. Before shifting, 1 is the y-intercept. So after shifting, 1 will go to the left. So after shifting, initially 1 is here. After shifting, 1 is no more y-intercept. Instead of that, other point will come and intersect with y, becomes new intercept, becomes new y-intercept. So means we need to find the new y-intercept by calculate x equal to 0, sub x equal to 0 into the equation. So we find that the new y-intercept is equal to e. So we label e here. So remember, do not press calculator to get the e and label the e in decimal. Straight away label the y-intercept as e. Then after that, complete with all the label of y-axis, x-axis, and the origin. So that is the curve. Now we look at next example. Sketch the graph y equals square root of 3 minus 2x. First, identify the parent graph. So now, since we can see that it's a square root here, so means the parent graph is a square root function. So we can start from the parent graph, square root of x. Next, we need to see, is there any negative in front of x? So yes, we can see there is a negative in front of x. So means the whole curve here need to be reflected by using y-axis. So after reflection, so the curve looks like this. So next, we need to see, is there any constant in front of x? So now it is a 2 in front of x, means we need to carry out enlargement by using scale factor 1/2. Now, since scale factor is less than 1, so means the image compared with object, the image should be nearer to y-axis because the center is y-axis. So means the image should be nearer to the y-axis. So after enlargement, the image should be like this. So now we look at the critical point, the 0 here. Since the 0 is at the y-axis, which is at the center, so 0 is unchanged. So means after the enlargement, the graph will be like this. Looks higher than the graph before enlargement. So next, we need to see whether it is a plus or minus a constant. So we can see that it is a plus 3 in front. So means we need to do the translation either to the left or to the right. So to determine that, so we make 3 minus 2x equal to 0. 2x equals to 3 means x it is positive 3/2. So means we need to do translation to the right for 1.5 unit. So means the whole curve should be shifted to the right hand side for 1.5 unit, included the 0 here. So the whole curve will be shifted. So after shifting, so the curve is like this. Now we look at the critical point. Before shifting, it is 0. After shifting, this point will come to here. So because shifting is shifting 1.5, 3 over 2 to the right, so the 0 now will becomes 3 over 2. So we need to label here 3 over 2. Then now we can see that after shifting, before shifting, there is no y-intercept except 0. But after shifting, we can see that 0 will become 3 over 2. Now after shifting, here there is a new y-intercept here. So means we need to find this value. So since it is y-intercept, means x it is equal to 0. So we sub into the equation. Sub into the equation. So y it is square root of 3. So means the new y-intercept is square root of 3. Then after that, please make sure all the label must be complete. So finally, this is the curve. Now you can try this exercise.